Hey, Jared.
Hey, Jared. How's it going?
Okay, how you doing?
Pretty good. My daughter is going to bed now, and my wife just left for the gym,
Uh-huh.
so she's kind of crying on and off. I might have to go take care of her.
Okay. How old's your daughter?
She's 2 months.
2 months. Wow,
10.
congratulations.
Yeah, thank you.
So, what do you know about the final project? I don't know that there's been a lot of specifics about what we're supposed to do with that, but it looks like we've got something due the end of this week. Oh boy. Hmm. Well, how's everybody doing tonight? I was just looking over the final project Have you guys had a chance to look at that yet?
Yeah.
Interesting. Yeah, I did.
Yeah, looks fun. So, is there something we need to get approved beforehand? I opened up the final project overview and that it pulled up a Word document that's got a bunch of steps in here. So I guess that's the first thing we need to do this week, or first thing we need to turn in this week. Okay. Well, we want to.
For the overview?
Yeah. So there's an assignment. Well, at least on iLearn, there's a
Yeah, there's like
marker.
5 portions to it.
Yeah. And it looks like we need to assign somebody to each portion, and then the collect data is something we all work on. So maybe we can do the assignment tonight, and then we can talk about the project. Or do you want to talk about the project first? I don't care.
Either's okay with me as long as we do it quick.
All right. Well, let's do the assignment first, then we'll see what time we've got left. Okay, so
Just waiting on Zach and Jared to get back.
okay, I think Zach is out. I think I got a message from him that he's got a test or something.
Okay.
I thought I got a message to that effect. Jared's Mr. Mom tonight. Well, maybe while he's doing his thing, we can talk about the project. What do you think about that?
Okay. That'd be great.
Okay. So I guess we have to decide a topic to study, right? Or we have to design a study. Does anybody? Did you see the list of things that they maybe some possible topics? Are brand A paper towels stronger than brand B? Are there 1,000 chips in every bag of Chips Ahoy? Is there a difference in the price of books at the BYU Idaho bookstore compared to those available online? Are men or women likely to walk on the grass if they're walking behind someone who walks on the grass? Are the distribution of colors between plain and peanut M&M equal?
I don't even know how to figure that out. Oh, the distribution of colors. I see. Like, there's that one actually wouldn't be a hard one to do for data.
Yeah.
Yeah.
And it would be enjoyable.
Yeah, tasty.
Yeah, it would. Yeah.
At first, I was thinking like, how would we, like, I don't know. I thought I was comparing greens and greens and see if there was like the same amount of dye, but that it makes more sense that it's each color distribution as a whole. So yeah, I think there's actually a percentage of like how many blues, browns, greens, all those colors.
I think you're right. That sounds familiar.
I think it was one of our actual assignments or something.
Sounds familiar.
Yeah, it's like 20-something% for most of them, and then there's one that's like 20 or 30% or something.
Yeah.
Couple.
Seems like the boring colors there's more of those.
Yeah. And we could even switch that up to something else if we wanted to. To M&Ms, get little fun-sized packs of M&Ms or something.
Yeah.
Or I mean Skittles, not M&Ms.
My wife would prefer M&Ms. She's
Well, we'll all go and have a consensus of all our wives and ask them what they
Yeah.
prefer.
what they prefer.
Yeah. I think
So-
M&Ms would be great.
Yeah, it might be a good one.
Otherwise, it would be because I mean, like watching men and women walk on grass might be a little creepy and
Yeah.
time-consuming.
Absolutely.
And I don't want to buy a bunch of
Chips Ahoy
Chips Ahoy or toilet.
or paper
Towels.
towels. Yeah.
Mm.
Yeah. We could do the prices of books. That would be interesting. But-
Yeah.
We could even do something like Amazon versus another online. I don't know. Maybe not.
Newegg or something.
You know, if we started without Jared, I bet you he would not
I bet he wouldn't even.
feel offended.
No,
Yeah.
I think you're right.
So
You want to do that?
yeah.
So, so
Let's see. Stage research. What population? Studying. Null hypothesis. So are we supposed to assign this to a person or?
the design the study you assign to one person. Describe the data you assign to one person,
Okay.
and they're the primary writer. Same with make inference, take action, and
Okay.
Oh,
PowerPoint. Let's see, what is it? So one of the things we're turning in is we have a main writer for the designing the study,
Mm-hmm.
describing the data, making inference, taking action, and the PowerPoint. So we have 5 people in our group. Is that right? Yeah. And then everyone fills out a group evaluation, and everyone does their collect the
Hey,
data
Chloe.
document.
Okay. And I think my professor actually talked to me, or the instructor talked to me about this and was mentioning that during the group project I just have to let her know what portions I was submitting, and I'd probably just give you, one of you guys, my copy,
Okay.
my portion,
Okay.
and I'll see. I can do this first portion of it, and
Okay.
then let my instructor know about what it is and give you guys a copy. That way I can figure out what to do for the rest of them for myself.
Okay. All right. And I wonder if our instructor even knows that you're in our group.
Yeah, she does.
She does. Okay.
Yeah, I talked to her about it.
Talked to
A couple
Okay, all right.
emails.
Oh, cool. All
She-
right. Sounds
yeah.
good. Okay. So you'll do the design the study part.
Mm-hmm.
Okay. So you've got part 1. I'm going to be out of town the week of the 10th. Well, I'm leaving on Friday the 10th, and we'll be gone most of the week of the 11th. So if I could do one of the week 12 ones, that would be a little easier for me if that's okay. So inference or action.
Okay. You know, I'm just thinking if we do the M&Ms thing, we could even break it down a little bit further and say like the distribution of each fun size pack, and you could just go to the dollar store and buy one thing of like the 6 or 10 or
Yeah.
2 of the 610 and have it broken down to the individual distribution of the fun size.
That might be fun.
So, and that way you get to open them up Or it's easier not instead of counting like a whole bag.
Yeah,
Yeah.
so we're just doing the
More
little packs,
specific.
the fun size ones.
Mhm. And that way it's only like $1 or $2 or something.
Yeah.
Per-
I like it. So then how would we do that? Would we calculate sample means for each color?
It would be a Nova then,
Okay.
Yeah.
would it?
Yeah, probably would be an ANOVA.
We did it per pack.
hmm
Maybe a lot of packs. Or a lot of little cells or whatever.
Yeah, a lot of numbers. So we could limit it to, since there's 5 of us in the group, if we're all doing.
Or what if we all did like an ANOVA and we all submitted our individual totals?
Well, if we're doing the ANOVA thing and we did it by colors, we wouldn't have to compare. We'd look at the proportion of.
Oh yeah, per how many we got per
So
person.
we just do plain or peanut. We wouldn't have to do
Mm-hmm.
both, right?
Yeah.
So what would our hypothesis be? What would our statement be? That there is.
Equal distribution or null mean of the null hypothesis. The mean is 0.
Oh yeah. Yeah. Okay. Because then we would find out that then we would actually look at what the proportion of those are.
Because we want to look for a deviation,
Yeah.
right?
Yeah.
Not because we assume that they're equal.
Yeah.
So then we take okay.
But that would tell us one or more of them is not.
Mm-hmm.
Okay.
Does that sound good?
Yeah. Are you okay? You guys okay with that?
So
Yeah.
we're doing M&Ms, and if we're finding out if there's a difference, or like if there's more of one color than the other.
Yeah. What we're going to say is that we assume they're all the same.
Right. Yeah.
That's the null hypothesis.
You
And
know,
then
like the little M&Ms or like the big bag of M&Ms.
we're going to do the fun size.
The little dollar store pack things, or the little whatever you can get for $1.
Yeah. And
So then we'll do. So I'm thinking each column, the up and down ones, would be each color,
mhm,
and then the rows across would be our numbers that we get for the colors.
right,
Okay.
of each one.
Yeah.
And do we want to do how many packs each? Do we want to do 5 or 10 or?
I think. Yeah. 10, 5, 10. Anything's good with me.
Because I think if we bought one of those, fun size Halloween ones, there'd be at least
10.
10 in there.
Yeah, we could do 10.
We could count up 10. You guys okay with that?
Yeah.
I'm having a hard time thinking of how we're going to use ANOVA to do it, though.
I can
Because
make
ANOVA,
up that. So here, I'll change this really quick and then screen share it. Green, brown. There's 5.
Yeah, there's yellow, red.
Blue.
Okay, so I'm gonna screen share and show you guys. So this is what I was thinking. So then we go, like, the first column across would be one person's. Oops. So like, this would be Ian's, this would be yours, mine, other Jared's, and then
Oh.
Zach's.
Well, okay, I was thinking we'd each do 10 and we'd have one per pack. So then you'd have a variance by pack.
We could do that too. I mean, so it'd be pack 1, 2, 3, have it go down.
Yeah, and we'd have 50 data points.
That'd be good.
That'd be a good sample size.
Yeah.
Yeah.
So then we would, just have each individual or each color listed there. Does that make sense, Jared?
Sounds good. So how many packs are we getting a piece?
Oops.
10.
10 packs. Okay.
Oops. And some funky numbers. Well, anyways, that's the whole point of it.
Yeah, that sounds good. That will work.
Okay.
So to the homework.
Okay. Just one more thing, just for assignments. So Austin's going to do step 1. Right?
Mm-hmm.
Does anybody want to describe the data?
Yeah, I can describe the data.
Okay.
Do they just want this on a plain Word doc? Oh, I can list the name of my group members on here. There we go. Makes it easy.
Yeah. Do you see if you go all the way to the bottom on the course menu, you can open up the final project overview,
Mm-hmm.
and then there's a Word document in there that you could submit.
Yeah, and I have the Word document up. I'm just wondering if they want us to.
Oh, I'm sorry. Okay.
Because it says each group member sign below that they.
Yeah. Yeah, that got kind of serious, didn't it?
Yeah. So
Each
I'm just
person is
wondering.
academically and legally responsible for their project.
Contract.
Yikes.
Legally?
Yeah, legally.
What's your last name again?
Humes. Humes.
I knew that. I don't know why. Okay. And then Jared. Jared, what's your last name?
Eardinep.
Other Jared. Sorry.
Oh, Ferguson. Ferguson.
Had a Ferguson that I played baseball with for years.
Nice. We're everywhere.
Okay, and then we got me, of course. I know Zach's last name.
Yeah, it's Bowen. I can do the make inference or the PowerPoint. What do you have a preference for, Jared? And we'll assign Zach the rest.
Let's see what the take action is.
What are you going to do if you find more yellows than browns?
I want to eat them all. That's what I want to do.
We're gonna chow down on them.
I don't know. Maybe there's too much yellow 5s going on.
In this case, since we're doing an ANOVA, our action might be look at the results individually and find out which one is actually different. I don't know.
I could either take action or make the PowerPoint. I'm gonna go with either one of those. So I could.
Okay.
Yeah.
Let's. Why don't you do take action and I'll do the PowerPoint and we'll give Zach the inference.
Yeah. Okay.
Do that? Okay.
Yeah.
So, real quick, the population to this, would it be the packs or the individual M&Ms, the total M&Ms? It would be the total M&Ms, right?
Yeah, I think you're right. I think you're right. It would be the total M&Ms.
For ANOVA, it goes based off of the actual number, or is it the individual entries? Oh, I think it would be packs. because that's what each value is going to be representing is
Packs.
that unit is like, because otherwise it would be like, let's say you're doing height of different age groups or something like that. Each number would be a person.
Yeah.
So this is each pack, and the population would be the number of packs.
Yeah, that makes sense. Hey, Austin, is your last name Simmons?
Yes.
With a D or without?
Simmons with an S. Simmons.
Okay. Like
Mhm.
Richard and Gene?
Yeah.
Which one do you like being compared to more, Richard or Gene?
Oh man, I've been teased about that all through high school.
Sorry.
No, I don't really associate either of them. There's for a while I had another person that I was like, oh, I'm actually more related to. Like, there's a black basketball player named
Yeah?
Austin Simmons.
Hmm.
Yeah, he was in the NBA for a little bit, and so I was like, actually, Austin Simmons, like uncle or cousin or something. But yeah,
So you associate yourself as black? Or is that just some...
as a
some
joke.
people?
Yeah. See, by marriage, of course. Right.
Right.
Let's see. Okay.
What was Zach's last name again?
Bowen.
Bowen.
Bowen. That's right. Okay. Okay.
So I
Should
guess
we-
this... Oh, go ahead.
Should we limit the population of packs to be just the regular ones, or should we even say that we're doing a difference between peanut, or like, I mean, saying peanuts and chocolate, or just peanuts?
I think we'd just limit it to plain.
Fine. Okay. I'm just trying to make sure I can understand all these questions. Design this study without you guys ever knowing what it's actually going to be.
Right.
Submit something like, we'll be observing birds and the colors of their feathers, and you guys are like, what? Okay. I'm ready for the homework if you guys are.
Cool, let's do it. All right, so from the list of graphs below, which graphs can you use to describe categorical data? That would be pie charts and bar charts.
Mm-hmm. Agreed.
So we want to do 2?
I can read that.
Cool, thanks.
When given a sample, what is the formula to compute P? Explain which each variable stands for in your formula. So N is the sample size, X is the number of, like the category, the number within a specific category, and P was the proportion to all of those.
Cool.
Okay, I got 3. What is the mean of the sample distribution of sample proportions? State in words, not just symbols. So the mean of sample distributions of the sample proportion. So that's like for the portion that you're looking at the it is like a specific number, and it follows the same as the population size, and it's different than the mean of the, like, a distribution of the quantitative thing, because the quantitative is like an area, I guess, of population. This is like a specific point number, which is the mean of the total population.
Okay.
Correct?
Yeah.
Let me see if, let me look at the answer then.
Yeah, the answer is a little shorter than that. It's just the proportion of the population.
Yeah. Okay.
I think it's a four. What is the standard deviation of the sampling distribution of the sample's proportion? That would be the square root of the population proportion times 1 minus the population proportion, all divided by the sample size.
Cool. Okay, what is the difference between categorical and quantitative data? So quantitative data is numbers. It has to do with numerical data. And a couple of examples of that might be the number of M&Ms that you counted, or it might be the number of people at a certain age. And then categorical data is the category. So if you were doing the number of people in a certain age, the age would be the category.
Or people's preference to colors of M&Ms, right?
Right.
So it'd be a color, not a number.
Right. Okay.
Okay, number 6. Open case file. Oh man, I don't want to do this. Create a pie chart. Well, we got a pie chart on the answer key. Looks great.
Looks good. Well, does anybody not know how to make a pie chart? You want to go over that? Because the data, they don't have a version of it in Excel. Oh, wait a minute. Yes, they do.
They do. I tried making a pie chart, but it's like I don't even know what they're using. I mean, like I know they're using rank, but like other than that, I mean, do you just highlight rank data and then hit insert pie chart? I mean, it looks like because you have to count, how many are ranked in this spot, this spot, this spot, and then you have to find out what percentage of the whole that is. I don't have a clue how to do that.
So,
For class rank.
Yeah, I don't see it. Oh, class survey. No, but that's under.
Is rank JR?
Yeah, I mean, like, rank isn't even a number, so, like, yeah, I have to go through and, I mean, unless I knew coding and say, like, if JR, say it equals 1, and then, like, count on the side, if 1 count, or whatever,
Oh, goodness.
But they made one, so, cool.
So it's possible. We just.
Yeah, if you want to go through, let's see, 184 data points.
Holy moly.
I heard her say data.
Yeah, she's still doing a lot now.
And so where is the rank?
It's at the very top. It's 1, 2, 3, 4, 5, 6, 7, 8 columns over.
Oh, it's a column H. Okay. Wait, no.
Column H. Oh, there's pie charts. Pie. Whoa. That did not come out to be a pie chart.
Well.
Donut? Nope. Hmm. I don't even see a conditional thing for manipulating the chart. Select data.
Okay, well, don't know how to do that.
Well, they made a great one, so.
Yeah, it looks nice. I super like it.
Good job.
All right,
Okay.
and they also made a bar graph.
That also looks great.
Yeah. Wonder if it's easier to do in SPSS.
It's at the third video on the homework. He goes
Yeah.
over how to do everything in SPSS.
Okay.
So he's like, yeah, maybe I'll do it on a school computer eventually.
Yeah. Hey, that brings up a question. On the test, did you guys use SPSS on the test, or did you take the values and convert them to Excel?
Convert into Excel.
Yeah.
Is that what you did?
Yeah, that's what I did. Okay, should we move on? 8 just describes the data, so 9 is 7% of the true unknown percent of the population. Oh, sorry, is the true unknown percent of the population who do not have traditional phones and instead rely on cell phones. 7%. Suppose a random sample of 750 telephone users is obtained. What is the probability that 60 phone users, 8% in the survey, will use only cell phones? What is the mean and the standard deviation of the sampling distribution based on 750 telephone users? So the mean is 7%.
Mm-hmm.
And then we need to calculate the standard deviation.
Yeah,
Does it
so
give
it's
us that? Yeah.
0.07 minus or times 1 minus 0.07
Yeah.
over the population square root.
Okay, so I'm going to kick it in my little spreadsheet here. 0.7.
Yeah, we don't have a
60.
Excel sheet for this one, so I made a little calculator.
Yeah, I did the same thing. 0.8. So, and that is not the standard deviation I wanted.
Make sure to square root it.
Is it the square root at the top or square
The
root?
whole.
You square the whole thing.
Okay.
Okay. So I got a square root of 0.059. What am I doing wrong here? Oh, sample size 750. Dopey.
Yeah, that would change it.
That would do it.
$750. We wanted 8%.
Yeah. I'm still coming up with something wrong. What am I doing? So the P is 7%.
I got 0.009317.
Yeah, that's what I got too. 0.093176. Or 3167, yeah. So that's not 0.009. 99.
Yeah, if you were to do it to the third decimal, it would still be wrong, I guess, according to that. So it would be 0.1.
Awesome.
Well, let's move on, because I'm
Okay.
pretty sure that's one of those little... I mean, the data looks outdated anyways. I think it's more than 7% now.
Yeah. Okay, so the problem in terms of the variable p hat So it's the 60 phone users divided by the sample size of 750. I wonder if
What
that's
is
where the...
the problem? Oh, this is to see if it's oh no, yeah, that's the probability that we're looking for.
Right.
Or the portion. That's what it is called.
Yeah, the proportion.
A sample of 60. Or a portion of 60 or something.
Mm-hmm. Okay, then they want us to draw a curve or a picture.
I can draw a curve.
Yeah, I'm just wondering which side of the curve we're... So are we looking at the right side of the curve above the z-score because
More than 60, yeah.
it's more than 60?
Did you get a z-score of 1.07?
Yeah, 3. Yep.
Yeah. Oh, and there it is right there.
Oh, there it is. Boof. Poof. Okay, so then keying it in the probability applet, which I don't have open. Does anybody have that open?
I'll get it up in just a sec.
Yeah, I got it right here too. .073. No, not 10.
Okay, and we want greater than 60.
Yeah, so is it 0.1416?
Yep, that's what I got, and that's what it's on there.
Okay.
I wonder what would happen if I plugged in the other number to Excel. Zero point zero zero. It would get us a different z-score if you did 0 or than 0.0099.
Is that right?
Yeah, I
So-
just tried it,
That has to be it.
and it makes sense that our z-score would be off.
Yeah.
So not.
But, so the z-score is based on the standard deviation of 0.093 or 0093.
Yes.
That's funny. Okay.
So it looks like there's a 14% chance that there will be more than 60 cell phone users in this survey.
Sounds right. You guys okay? Jared's, you guys okay?
Yep.
Okay.
Okay.
All right, so we move to the quiz.
Yes.
I'll take the first 2 questions.
That's generous.
Last time I got them wrong, so. Why are the slices textured different sizes? I think it says 2.
This is lesson 16, right? I didn't open up the wrong one.
Yeah, I was just looking at that too.
Yeah.
I put the second answer. Each slice represents a category, and the area of each slice represents the portion of the total occupied by the category.
Good.
Or it's the first one. Pie charts are more visually appealing. They're sliced in different sizes. One of the two.
People are more likely to eat pies when they are in thinner and wider slices.
So we went with the long answer. Represents
Yes.
the category and the area of each slice.
Yeah.
And
How are-
number 4 is the third answer.
Yeah, each slice is random.
Oh, I see. Number
It's like,
4.
did you learn nothing? Okay.
I like Pareto charts are constructed from tossing a coin several times.
I'm guessing we're going with the long answer once again. We conclude that p hat is normally distributed. Huh?
5 is A, right?
The true
It's just
proportion.
asking.
For the sample. Wait,
No, the one without the little
proportion
roof.
or the sample proportion?
The one without the roof is true proportion.
Yeah, the one with the hat on is the sample.
Yeah.
Yeah.
Jared, when you hear p hat, does it kind of make you think of like,
I was talking about. No, didn't I know that stuff?
the thing that patients pee into, and they, yeah.
Yeah.
The whole time in the videos he was talking about that, I was like, he said p hat.
Did he literally say P hat?
Yeah, he calls it p hat.
Yeah, it
I
does.
mean, actually didn't even listen.
What is N? N is
The,
number of Canadian candidates in an election. Number of successes.
this is a
That'll be it.
comedian wrote this one. This quiz. The sample size. If p equals 1/4, what is the smallest n that satisfies the requirement?
40.
What?
Oh, yeah. Is that right? If p equals 1/4, the smallest sample size would be, because it has to be greater than the one number, 10? Or am I thinking of something differently?
I don't know.
Because this is talking about if it's normally going to be normally distributed. So if p equals 0.25, this has to be 40. Oh, and the equation for this was, look this up real quick.
Is
I thought I
it
remembered it.
is it referring to question 5?
I thought this is because there is a formula that I had up there. I'm trying to remember what it was. I'll find it in just a second.
Is that the x over n one you're thinking of?
You might be referring to number 5.
It was,
If that's true, then it's easily calculable.
Okay, it has to be
Yeah.
n times 1 minus p. It has to be greater than 10.
Okay, so that's the
For it to be a valid.
If you say 10 divided by 0.75, then you get 13.332.
So it says
So,
here that
14?
in order for it to be a normally shaped distribution,
Yeah.
it has to, NP
Okay.
has to be, so n times p has to be greater than 10,
right.
and n times 1 minus p has to be greater than 10. So if
Okay.
n,
So the formula is in question 5. So we just need to plug p into that formula. Man, so you come up with 40.
1 minus 0.25 or 0.25 is 0.75. We divide it over into 10. 10 divided by 0.75 is 13.333.
Wait, what?
So if it's 13.333, then you have to round it up to 14, right?
Sorry, say that one more time.
So if you're looking at the equation, well, I suppose you don't even have to do the second part, but let's see, 0.75, so 10 divided by 0.25, oh, it's 40. I see what you're saying. I was doing the other one.
Oh,
Uh,
yeah. Oh, but it has to meet both criteria. So you're
Yeah.
at 1 minus 0.25 is 0.75.
yeah,
Okay.
and then you divide that over the other side,
Yep.
and it comes out to 13.233.
Okay.
But that
Right.
means it has to be 14, right?
40?
So I think 40 is the answer.
Well, I got four. Wait, what? The smallest. So the 40 has to be the smallest number.
Is the smallest. It doesn't have to be. Or it
Oh, I
has.
see. Oh, I see. Okay. Because if we
It's,
put 14 into the other equation, then it would be too small.
yeah.
Right. It
It's
wouldn't fit the
1/4
first
of.
half of the equation.
Yeah, it has to fit both.
Okay.
That makes
So
sense.
the way that I figure is like if something satisfies the second portion, then it should satisfy the first. Is that right? No, because that's how you figured it out. The first portion. I guess you have to figure it out both ways, anyways.
Yeah, I guess you would.
Mhm. The largest number has to be the smallest number.
It's kind of lame
Yeah, that is kind of lame.
to figure out both of them.
How could it be? It's weird. Okay.
Well, I'm just gonna do. Yeah. No, we can move on.
Okay. 8. Use the following information to answer questions 8 and 9. Suppose n equals 24 and p equals 0.04. What is the mean of p hat? Is that 0.4? Oh, no, it's not. It's 0.4 divided by 24.
Yeah, which is 0.041667. So what are you rounding to in this thing?
Rounded
What
to
did,
2 decimal places, so it's 0.02.
what did we say number 8 and 9 were?
Oh, geez. Well, how many decimal places do we round the mean to? 3? Sorry, on 8?
I could plug this in, I guess.
Oh,
Do we get 0.01? 017 for 8?
What did you put in for the sample mean? Or the mu p?
For which number are you guys on?
Oh, yeah. Okay, so are we on? We're on number 8 or number 9?
For number 8, I got 0.017.
Yeah. Okay, so then I'm putting that in as
are we doing to 2 decimal places?
3.
Yeah, okay.
And a standard deviation of 0.1.
That's what I got.
So 0.100.
I don't know. Let me see. 0.100. Yeah.
Batting average is 0.3. So we'll get more than 30 hits in this. And then you want 0.5 and a sample of 100. P hat. Round to 2 decimal places. Has anyone plugged in all the stuff for 10 yet?
I'm working on it. $100 at bats.
Oh, that's what I did wrong. 1.0. Or I guess no, it's still.
I got a standard deviation of. Oh, wait.
My P hat was 0.35. I don't know if it's right though.
So for your, you put 300 or 30. For your portion.
So for the X value, which is number out of the entire population that is well, anyways, 35 hits, right? So X should be 35,
Yeah.
N is 100, and population P is 0.3. My P hat was 0.25.
So P hat is X over N, right? So that's 35 divided by 100, which is 0.35.
Okay, that makes more sense.
So how did we calculate the P hat in number 8?
I have no idea.
P hat I took. P hat equals
I think we calculated that
P
wrong.
divided by N.
Is that what it is? Because
According to the video that the teacher had.
I have the lesson up, and I have P hat is X over N.
X
Yeah.
over N.
So, but isn't there also something that says P hat equals P? Where do I?
Okay, P hat equals X over N, where X is the number of individuals with a certain characteristic. So it'd be your. So that equals your test or your sample proportion. Or sample.
Yeah. So that's the formula for.
What is the mean of p hat?
So the mean of p hat equals p.
Yeah.
So then what do we know in question 8?
Yeah.
What is the mean of p hat? That's p. So that's so the answer for 8 is 0.4.
Yes.
Yeah.
That's right.
Okay. So then how do we calculate the standard deviation of p hat? So do we have,
Shouldn't.
that should be 0.4 and 24 and 0.4. So that should be 1, which is what we have. Does that sound right to you guys?
So I set up my own little calculator thing for p hat and all that other stuff. Once I put in the sample and the population proportion,
Uh-huh.
no matter what the x value is, the standard deviation is always 0.1.
Okay.
For no matter what. Wait, say that again. No matter what the sample proportion or sample size.
If they're equal,
Yeah, it's 0.1 no matter what I do. As long
if
as
p and p hat are the same.
well, p hat doesn't even account in the equation. Remember, standard deviation is just p times 1 minus p divided by the sample size square root.
Oh, you're right. Yeah.
So all you do is just use the population proportion, and it's 0.1. I'm just wondering if they want it 0.1 or 0.100.
I don't know. That's a good question. I think I'll keep the 2 decimal points.
Did you put 0.400 or 0.400 then?
Yeah.
No, no. We can always bug the teacher if it's wrong.
Yeah.
Very, very. You know,
Yeah, we
there's
were
a way.
told to do round to
Yeah,
3 decimal points unless we were told otherwise.
I didn't see that in there.
Oh, I'm just saying in general. All the tests say that.
Yeah.
Oh, well, there is a way that she can go in and say the answer is this or this. I mean, it doesn't have to be just one
Yeah.
answer or key answer. So, whatever.
Okay, so what do you guys have for the standard deviation on 11?
So
No.
I got a value of 0.458.
Oh, that's not what I got.
I got 0 or 0.0458, and I rounded to 0.46.
Oh, okay, yeah, that's right, 0.045.
Oh, okay, yeah. All right, that's what I got too. 0.046.
I have the same.
Okay. And the z-score is 1.091.
Yeah.
Okay, and the probability, Brittany gets at least 35 hits. We go back to
Sorry, what was the z-score again, real fast?
1.091.
It's probability that she gets more than, or at least.
Yeah, so it would be greater than, because it's greater than her average of 300.
Which comes out to be
0.1376.
Yeah.
So 0.13.
13,
0.138.
13.8%.
Okay. Okay, 0.13. Jeez, come on. 0.138. Okay.
So, 0.50.
Okay, for 14, P is 0.052, N is 2,000. We want to determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50% of the votes. So
What is the standard deviation of p hat?
I have 0.011.
Yeah.
And a z-score of negative 1.79. Is that right?
90.
Yeah, 790. And the probability we're computing is less than z.
Big Z or little z?
I'm going, I don't know. Big Z is a little smaller than little z.
So the second option?
That's what I think, but I'm open to ideas.
I really don't know what it means by little z and big Z.
Yeah.
Let's just pick the less n sign.
That's what I was thinking, since it says less than or losing the election.
Yeah.
That's nuts.
Because it should be that what
shouldn't
you're
be-
proposing is the first number is less than
Shouldn't
the
it
null?
be P and P hat? I mean, those
Or,
are the,
yeah.
the null and the alternate.
So, yeah, I'm taking the second one. Big Z is less than little z. What is the probability the survey results will show the candidate is losing even though the true P is 5.2 or 0.52? I'm confused what it's even asking about.
So I think we put the z-score in. Negative 1.79.
I got 0.037.
Yeah, that's what I got too. 0.0367. So 0.037. What do you guys think?
That's what I got. So
Jeez.
0.037.
Yep.
And that is what is the probability of a type 1 error?
So yeah.
Kinda. Not really, but I mean a different way of looking at it, but
Yeah.
I'm submitting it.
Okay.
And we got 100%. Yay.
Nice.
Big Z is less than little z.
Sweet.
Was that? Sorry. So Is anything wrong?
No, we
100%.
got 100%.
If you wrote it the way we wrote it.
Okay, so right, but we're doing 3 decimal places on everything you're left specified, right?
I did 3 decimal.
Yeah, that's what I did too.
All right. Sweet.
Hey, Amber.
Oh, yeah, there's one.
No.
All right.
Okay, thanks, guys. Cool.
Yep.
Thank you. Austin, I'll send you your stuff.
Awesome. Thanks. See you.
So, yeah,